Okay, thank you for joining back. Welcome back. So we're on this question. So I was trying to explain it using Excel, how to do it using Excel. If you are to do it by hand, after getting to this stage, all you need to calculate the value of the intercept using the formula we derived and the value of the slope. Then the slope is given by this, then the intercept is given by this. So you've gotten your K and your K max indirectly. But want to use Excel now. So the way we use Excel is that we want to get our K and our K max. That's our objective. So first of all, we'll put random values of K, of capital letter K and K max. We just put some random values there. Then F is given to us as our data point. Then K is our output. So after doing that, we just put in random values in order to be able to calculate for this expression. Then after that, we get our K. The K we are getting is our prediction, is the K prediction. But K is given to us in the question, and this is the K. This is the K that is given to us in the question. But using this formula, we've been able to, and using some random values, we've been able to predict K. So the objective now is to minimize the sum of the squared differences between the K predicted and the actual value of K that is given to us. So that's the strategy we are going to use. We want to get our K max and capital letter K, which we don't know, but we just assume some very random values of K and K max. Then we use this, so we put in the assumed value of K max into cell Q1. Then we put the assumed values of K, assumed value of K, sorry, in Q2. So we know F is given to us as our data point. Then we use it to calculate our K. So when the K we calculate is the predicted value. Since some actual values of K were given to us in the question, we subtract the K predicted from the K. And the objective is to minimize the sum of the squared differences between the predicted value of K and the actual value of K. So this is what you are going to do. Then this is the Excel format. Then after that, this is the representation in Excel. Then we'll find this, you find the difference between the predicted value. So this equation is what we predicted, and we put it in cell C2. Then the actual value of K that is given to us is in cell B2. So we want to minimize the sum of the squared differences. So this is the difference, and this is the squared. They want to minimize the sum of it. So let me just go to Excel so that it will be much more explanatory. So this is the sheet. So let me just copy it so that I will start all over again. Then let me paste it here in a new sheet. So you have your F here and you have your K here. So we'll put in K max here. Let me put K max. Let me just assume a value of, let me just say 9. It's just a random value. Our objective is to find K max and K. So the value of K, let me just say 50. So these are just assumed values. Then based on that, we want to predict the value of K. Then in the question, so I'll create another column called K predicted. So this is the K predicted column. So in the question, we're given this formula. So we're given this formula in the question, which I derived in the note. So this is your K max, and this is your K. So your K max is in Q1. Then your K is in 50. So we use it to calculate the predicted, we use it to calculate the predicted value here. So then we drag it down for the others. So these are our predicted value. But we want to minimize, this is the actual value of k, and this is the one we're able to predict. So we want to minimize the sum of the squared differences. So simply put, we are going to subtract the k from the k predicted, then we're going to square it together. And after that, we'll drag it down. So this is the sum of the squared differences. So this column is simply k minus k predicted. And as k predicted, then squared. That's this column here. This column is k minus k predicted squared. So here is squared. Okay, so superscript. So here is k minus k predicted squared. So I simply subtracted b2 minus c2, then I squared it to get this. They want to minimize the sum of the squared differences. So in this particular cell, I will put in the sum of the squared difference. So I'm summing the squared differences and I'm putting it into cell D11. So here is the sum of the squared differences or squared residue. So this is SSR, sum of squared residue or sum of squared differences, anyone. So my objective is to minimize this. Remember I told you, if you're following in the last class, for linear regression, you want to minimize the sum of the squared differences. So yeah, we just used the formula. We got this from the formula, but actually wanted to get our k max and k, but we just assumed some values. Then we made some predictions based on our assumed values. Then we found the difference between the measured values, the actual values, and our predicted values. Then we squared it. Then these are our sum squared differences. So we want to minimize this, we want to drive this to 0. So the way you do it in Excel is that you go to this solver. So in case you don't have the solver, this solver button is on your data analysis, on this data ribbon. In case you don't have it, you would use the same method we used. You go to File, Options, Add-ins, then Excel add-ins. Then make sure this solver is ticked. So if this solver is ticked, this is going to appear here. So once you've done that, you are going to click on this solver. So the objective is to minimize this sum of the squared error, to turn it to 0. So the objective is that this particular cell D11, this is D11, we want to set it to a value of 0 by changing cells Q1 and Q2. By changing cells Q1 to Q2. So if you can remember, we actually did this when we were finding the roots of equations. So the objective is that we just assumed some values of k and k max, but actually want to find the value of k and k max. But we just assumed some values. Then using the formula given to us in the question, we predicted some k parameters. Then we found the squared differences. Then we found the sum of the squared differences, which is in cell D11. This is D11. Then want to set, the objective is to drive this cell D11 to 0 by changing the variables in cell Q1 and Q2. So once, and you click select a solving method, is non-linear because it's a non-linear equation. The growth rate saturation model is a non-linear equation. If it was linear, we would have clicked on simple LP, that's linear, but it's non-linear, so we leave it as GRG non-linear. So once I click on solve, it's going to drive this D11 to 0 because that's our objective. And it's going to change, it's going to give me the values of K and K max that will help us to fulfill an objective of driving the sum of the squared residues to 0. So immediately I click on solve, this and this, they're going to change. And this is going to change to almost 0 because our objective was to drive it to 0. Then the values that is here and here is the value of K max and K I'm looking for. So once I click on solve, okay, then this is the value of K max and K I'm looking for. So this is the way to do it in Excel. The next, so I try to explain the steps in the notes. So we're going to use MATLAB now. So we are almost done with the class of today. We are going to use MATLAB to fit polynomial and also to calculate, to interpolate. So MATLAB has a function called polyfit. So it's used to fit a polynomial. Therefore, interpolation, it has a function called interp1. So interp1 is for 1D interpolation. So we did 1D interpolation by hand. Interp2 is for 2D interpolation. Then spline is to fit a spline through the data, though we do not do spline. It's much more complex, so I just keep this. Then also FFT. But I didn't do this also because it's Fourier transform and it's not within the syllabus. Okay, so we are going to want to do interpolation and curve fitting using MATLAB. So let me go to MATLAB now. MATLAB. So I'm in MATLAB now. Then want to fit some set of data using MATLAB. So this is, so now I've already written the code, I just pasted it here. So this is the value of X is from 0 to 10 in steps of 1. So if you didn't put any steps in between, it's going to default to a step of 1. And this is the value of Y. So this is the different values of X, and this is the value of the function, which is just sine X. Then this Xi is what we want to use to, it's just, this one is, the value of X here is quasi spaced, but here is more finely spaced because the steps are 0.25. Then we use this interp1 function to interpolate the value of X at this finely spaced instances at X1. So simply put, you are giving this X value and the value of the function at that particular X value. Then you want to interpolate this more finely spaced values of X. So this is the points we want to interpolate, but we are given this and this. So we just use the interp1 function. So X and Y are the values that are given to us in the question. Then Xi is the value we want to fit into that we want to actually interpolate for. Then this plot function is to plot the values we're given as O, then the values that we actually interpolated, we'll plot it as just a fine line. So simply put, we're given this sets of data points, X and Y. So this one is from, X is from 0 to 10 at intervals of 1. So X is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're given the value of the function of Y. So it's just sine X. So Y is just equal to sine X. And based on this, we are asked to interpolate at this instances 0.25. So this is much more, is not finely spaced, but this is much more finely spaced. So this was actually what we are interpolating for. So when we plot it, it's actually going to give us a new figure. And this is the figure you're going to see. So this is the point, these all points are the points that were actually given to us in the question. So this X is equal to 0, X is equal to 1, X is equal to 2, X is equal to 3, X is equal to 4, 5, 6, 7, 8, 9, and 10. So this is a sine curve, but we're using linear interpolation. So remember the xi is what we wanted to find. So it's in steps of 0.25, 0.25, 0.25. In between all of this is 0.25 instances. So it used a straight line to actually interpolate. So it used a straight line to interpolate for xi. So that's how to do interpolation in MATLAB. So this is the data point you are giving, the one I highlighted. This is the one you want to interpolate. So you just call this interpolation on the data point you are giving and what you want to interpolate, the values you want to interpolate for. So that's the way to do it. So let's move to another form of interpolation we can do in MATLAB. So it's the polyfit. So in the polyfit, we are using a polynomial to, you want to fit a polynomial. You want to fit a polynomial through the data point. So here, in this previous example, we're using a linear line. No, I told you that a linear interpolation is not so accurate. But now we're using a polynomial. So this is the function here. This is your x, and this is your y, which I've already specified. Then this 5 means a fifth order polynomial. So you are fitting a fifth order polynomial through the data. Then the result is going to be, we call this polyval function based on the results, based on this fifth order polynomial. Use it to interpolate for the unknowns, which is xi. Then you're going to plot it. So when you plot it, we arrive at this. So this is like a polynomial. In the first case, we used a linear line. So that one was just like straight. But here is like a curve. We are using a fifth order polynomial. So this is the way you fit a curve in MATLAB. So let me go over it again. So this is your x value. Your x, so this is when you do this, it's going to give you the fifth order polynomial. So this is the way MATLAB expresses a polynomial. It's a fifth order polynomial. So this is probably x raised to power 5, x raised to power 4, x raised to power 3, x raised to power 2, x raised to power 1, then x raised to power 0. So this is the polynomial it's generated. Then based on this polynomial, it was able to interpolate using the polyval function and using this line here. Then here we just simply plotted it. So this is your x, and this is the x value you were given in the question. This is the y value, which is also given in the question. And this is the xi. This is what you want to, these are the values you want to interpolate. So we're given, let me put in the x. This is the x value we're given, but xi want to interpolate at this point, at this point, at this point, which we're not given in the question. So this is the x value we're given. It's just 0 to 1, 0 0.25, 0 0.5, 0 0.75 we're not given. So here to 1.25, 1.5, 1.75 we're not given. So these are the points we want to interpolate. Then up to 10. So we first of all used linear interpolation. Now we're using polynomial interpolation. So the last method is you can use a spline. A spline is much more accurate than a polynomial. So now you are fitting a spline through x, y, and you want it to interpolate at this xi, which most of it are unknown. So if we fit a spline through it, it's going to be much more accurate. When we fitted, this is the graphical, when we fitted a polynomial, it fits other polynomial, it was not really touching these data points we're given. But when we fit a spline, when we fitted a spline, the curve passed through all of the data points. Then for 2D interpolation, so I said for 1D interpolation, the command you use is interp1. But for 2D interpolation, the command you use is interp2. So this particular x, this was what we were given in the question, that question on bilinear interpolation. This is our x1, this is our x2, this is our y1, and this is our y2. This bilinear is exactly the same question. So we're given a surface, is a four-corner surface representing a triangle. This is our x1, x2, y1, and y2. Then this z is the temperature at this point. At x1, y1 is 60. The temperature at x1, y2 is 57.5. The temperature at x2, y1 is 55. And the temperature at x2, y2 is 70. This was the exact question we did, that we used Lagrange to solve it. So in MATLAB, you can simply just call the interp2 function. So this is your x, this is your y. It's representing x1 and x2. And this is representing your y1 and y2. So your z is a 2 by 2, representing the values at x1, y1, x2, y1, x1, y2, and y2, x2 and y2. This is your z. Then this, you want to know the temperature at this point in the surface. This is actually the four-corner surface. But you want to know the temperature in between at this point. So when you call the interp2, so this was the equation. This was the answer we got when we used it by hand. So this is using MATLAB to do the interpolation for us. So let me go back to the notes. So in the notes, I tried to, and this is the question. So this is your X and your Y, which is given to you in the question, but you want to fit this data points, which is unknown. Most of it are unknown. You want to interpolate your known values. So like we did, we used linear interpolation, a straight line. Is not so accurate because the curve is actually a sine curve. So it did not, the line did not really capture the exact form. Yeah, we used a polynomial, a fifth order polynomial. If this one was 4, that's the fourth order polynomial. Then we fitted it through the data point using interpolation, but it's also not so accurate. Then we use spline. Spline is the most accurate of all. So it passes through the data point, showing the full nature of the sine wave. Then to do 2D interpolation, you call the interpol method. Okay, so thank you everyone. So this is like the end of the class for today. So by next week, we are going to go into integration. So this particular, okay, let me, you have a question. Let me unmute you so that you can ask your question. So unmute. I've unmuted you. You can ask your question.
Okay.
Or you can just type it.
Okay. It's not based on what we did today.
I can't hear you.
It's not based on what we did today. I just want to ask concerning our project.
I can't hear you. Can you type it? You raised up your hand. You can ask your question or just type it. Okay, for the project, you can, for the project, I put you into groups. Then on Moodle, any one of you can upload it on Moodle. Any one of you can upload the project. Then you just state your contributions in the report. But in order to be on the safe side, you can also email it to me. You can also email the project to me, but make sure you also submit it on Moodle. But you are free to email it to me if you want to. But on Moodle, I think any one of you can submit. It's not everyone that should submit. On Moodle, there's only one person that can submit. So probably the group leader or anybody the group chooses can submit it to me. Okay, but if you need to, if you need more time, if you need more time for the project, I can give you just let me know if you're going to be submitting. If you cannot meet up with the deadline, just let me know how far you've come with it. So, so this is like next week we are going to have a class, and that class is going to be like the last Zoom lecture we would have, because I'm almost done. So the next class is on integration, and is kind of, the others we've kind of touched on it. So next class is going to be like, okay, if you, for those of you, if you want to extension, it's okay. So it's okay by 1 week. For those of you that want extension, so I'm extending it by 1 week. So for those of you that can't meet up with it, it's okay. But if you want more than that, just let me know. Just inform me that, just send me a mail that you are running late and you can't really meet up with the deadline, then it's okay. So it's okay, it's okay to submit late, in as much as you tell me that you'll be submitting late, then it's perfectly okay. So like I was saying, next class is going to be the last Zoom lecture we would have. So after next class, I will still be uploading some materials on Moodle and be giving you assignments also. But it's just going to be just assignments basically, and few limited information. So as from, there's going to be a class next week. So that will be the last class we'll be having on this lecture. So like I said, if you want an extension, just let me know, and before you submit. So I will still be, after next class, we'll still be interacting on Moodle, but we're not going to be having any physical classes anymore. I'll just be giving you assignments and quizzes, that's all, and some readings to do. So